Okay, Andy. Good morning, everyone. So the last class anyway, in applicative area, the inheritances are categorized into two types. Single inheritance and multiple inheritance, I said. According to Java language, multiple inheritance using classes model is not available in Java. Your author said, whenever we take a multiple inheritance using classes, replication of programming components may come. Because of this replication of programming components, ambiguity will come. Ambiguity means confusion. This ambiguity state applications will generate wrong results. That is the reason given. Okay, right? But according to object-oriented programming language, the language has to support all the object-oriented features. In that process, whenever we want to achieve multiple inheritance in Java, we take the support of interfaces. That's the theory. In that process, we are entering into interfaces practical today. Sir, what is interface? Interface is a collection of variables and abstract methods. Whenever we started a class is a collection of variable, method, main. We started like this. After that, it became variables and methods subclass. After that, we added blocks and constructors. That is the process we done. Here also, starting definition is interface is a collection of variables, methods only. But the methods are abstract methods. It's a theory. So interface is a collection of variables and abstract methods up to Java 7 version. It's a theory. What is this abstract methods? The methods which are declared without method body are known as abstract methods. The methods which are declared without method body are known as abstract methods. It's a theory. What is the structure of abstract methods now? Return type, method name, parameter list will be there, body not available. It's a theory. Opposite to abstract method, we call it as concrete method. Opposite to abstract method, we call it as concrete. Here, somebody asked yesterday, concrete means body constructed and available. That's called concrete method. Body is already available. The methods which are declared with method bodies, we call it as concrete methods. Yesterday somebody asked simple methods. Any other words available? Simple methods, normal methods, all comes under concrete methods only. Other than that, we are calling it as abstract methods. It's a theory. There I stopped. Bit early yesterday. The reason, once we started interface practical, 2 or 3 programs we have to do. Then only you can understand the concept. Hope I am doing today. Can I start it now? Right, okay. Rule number 1. Rule number 1. In the process of learning interfaces, we compare with the classes actually. Who are attending 11 AM batch? Yesterday I used connection, one interface. statement, one interface I used. Okay, right. That are two interfaces I used yesterday. Practical. But without knowing the rules of interface, you started using them. No problem, we can use it. So rules are available in the Core Java book. Okay, right. Now here, sir, before entering into interfaces, we comfortably constructed one class. Then we are constructing interface. So this is one class. This is one interface. We are constructing interfaces by comparing with the classes. It's a theory. Okay, right. Now, we use interface keyword to declare interfaces. We use interface keyword to declare interfaces. Syntax: interface name. This one, your interface body. If not, you can write members. Interface name, and some members are available, maybe variable, maybe method, and so on. We use interface keyword to declare interfaces. Like class name, we had interface name. It's a theory. There we had class followed by class name. Some class body is there, no? Here also same. Interface name followed by interface body. That interface body I written members. I written. Okay, right. Now, rule 2. The members which are declared within the interface are automatically public. Automatically public. The members which are declared within the interface are automatically public. Automatically public. Sir, what is the meaning of that automatically public? Look here. If you write any variable in the interface, if you write any method in the interface without any access modifier, no public, no default, nothing. So automatically it takes public. Automatically the variables are public. Automatically the methods are public. They're only automatically public. Then what about classes, sir? We make one statement. The members which are declared within the class without any access modifier. The members which are declared within the class without any access modifier are automatically default. Automatically default. The members which are declared within the class without any access modifier are automatically default. So if we declare one variable without any access modifier in class, it is considered as a default. The statement already recorded in the package chapter to you already. But whatever the variable or method declared within the interface without any access modifier automatically considered as a public. That point you have to remember it. So here I am drawing like this. So whatever the components you declare inside the class, they are default. Automatically default. Whatever the components you declare inside the interface are automatically public. That point you have to remember it. Now you know already classes already declared with variables. So I brought variables here. We completed also. The discussion about variables in classes completed. The notes what is available with you is the variables in the classes indirectly. So you know very clearly variables in Java can be primitive data type and non-primitive data type. Primitive data type variables are there and non-primitive data type variables are there. I am repeatedly writing this anyway. Among this primitive data type, we had static and non-static. You know that already. Static is there, non-static is there. There, non-static is there. Among this non-static, you know, one instance is there, one local is there. One instance is there, one local is there. Here same, static and non-static. This non-static are instance and local. These are the variables. Okay, right? You know already that theory. Now I am bringing variables into interfaces. Variables into interfaces. I am declaring variables. A rule will be there. Interface can be declared with both primitive data type variable, non-primitive data type variable. Like classes, you can declare both. You can declare both. So you can declare primitive data type variables here and non-primitive data type variables. Both are allowed. And the variables which are declared within the interface are automatically static and automatically static, automatically final. That is the nature. The variables declared inside the interface, automatically they are static variables only. Without writing static keyword, they are static variables. And automatically final variables. Final variable is a new word, new concept now. Because up to now, final variable not entered. You know static variable already, but you don't know final variable. So the variables are static and final. Static and final. So record these 2 points like this. Rule 3. Rule 3. The interfaces can be declared with both primitive data type variables and non-primitive data type variables. The interface can be declared with both primitive data type variables and non-primitive data type variables. Can be declared with both primitive data type variables and non-primitive data type variables. Both are allowed. Right. Rule 4 to be remembered here now. Rule 4. The variables declared in interfaces The variables declared in interfaces are automatically static and final variables. Static and final variables. The variables declared in interfaces are automatically static and final variables. Underline static and final variables. The variables are static and final variables. Right. So look here once now. The class will be loaded onto method area. You know already. You drawn few diagrams. The classes will be loading onto method area of your JVM. While class loading, the static variable will get the memory inside the class. You know, you can access with the class name. Same behavior. Interface also will be loaded onto method area like class only. Right? Behavior same. Wherever the class is loaded, there only interface also loaded. So interface will be loaded onto method area. While interface loading, static variables will get the memories and you can access with the interface name. Make a statement. So note, N-O-T, note. Static variables in interfaces will get the memory within the interface while interface loading. Static variables in interfaces will get the memory within the interface while interface loading and can be accessed with interface name. Can be accessed with interface name. Static variables in interfaces will get the memory within the interface while interface loading and can be accessed with interface name. Like class only. While class loading, static variables are getting the memory within the class. The same way, while interface loading, the static variables will get the memory within the interface, access with interface name. Got it right? What is this final variable, sir? Final variable. Final variable means already you know, variables are used to hold values. Generally, in your variable, we keep the data. The data in the form of value, the data in the form of reference, anyone. So suppose I am taking one variable, roughly, I am taking one variable here. Int k is equal to 10, I took it. I took one variable, final int z is equal to 100, I took it. Now one is final variable, one is normal variable, right? What is the difference, sir? Means in the normal variable, whenever you want, you can change the value. If you want to load 20 somewhere, you can load it. Whenever you want to load some 200 here, you can load it. Means you can change the value available in normal variable. Final means last. Final match means last match. Final class means last class. Final variable means last value. That's the meaning actually. Once you given the value, that is the last value. Suppose if I try to load some value here, I want to load 20. You cannot modify this final variable. You cannot load it. So the value available in the final variable is final. That's the meaning. So the variables must be initialized with value. The meaning is Final variables you cannot take empty. Suppose I want to take final int z, error will come. It will ask where is the value for z. Means without a value, you cannot take final variable. Some value must be there. Once you given the value, it cannot be modified. So what is the nature of final variable? Means final variables must be initialized with the value. Means you must assign some value and you have to keep it. Final variables must be initialized with values. Once initialized, cannot be modified. Make a statement. Final variables must be initialized with values. Final variables must be initialized with values. And once initialized cannot be modified. Once initialized cannot be modified. Once initialized cannot be modified. Simply we can say final variables are secured variables. Final variables are secured variables. Variables are secured variables. Right. All of you look here now. Everybody will have a PAN card. Every employee will have one PAN card. Everybody knows. So whenever we want to take one PAN card, some person, some executive will collect some details from us. Some form will be there. We fill the form. He says that date of birth proof is mandatory. Provide your 10th class certificate. For date of birth, 10th class certificate is valid, no? So we'll give a 10th class certificate to him. There one date of birth is there. When they are filling the form in the online, date of birth field is final field. In that application, income tax department, the date of birth field is final. Once you filled that form, your date of birth linked to PAN card, it never changes. That only final. Understood this point now? Like this Aadhaar card number, bank account number, which one you cannot change it, their final field is available. Understood this statement now? So in interfaces, the variables are automatically final. In classes, options are there. In class, flexibility is there. You can take normal variable, you can take final variable. Final variable will come. Into the class also, final variable will come. Not now. Polymorphism chapter. Poly, many. Morphism, forms. Variable has two forms. Modified, unmodified. Like this, forms will come. That's called polymorphism. Poly means many. Morphism means forms. Variable has how many forms? Class has how many forms? Interface has how many forms? The discussion will come in the last. Only polymorphism. It's a concept actually. In polymorphism chapter, we bring that final variable into class. Up to now not entered. Now, interfaces are saying that we don't have a normal variable. The variables are final variables. The variables are static variables automatically. If we don't write final keyword also, they are final. If we don't write static keyword also, they are static. Because of this reason, they'll ask one interview question to you. Question is, how can we declare non-static variable in interfaces? One question is there. One question, how can we declare non-static variable in interfaces? The answer is, there is no concept of non-static variables in interfaces because the variables are automatically static. They will not allow me to take non-static. But the student will answer the variables which are declared without a static keyword in interfaces are non-static variables, they'll answer. They expect that answer only. So whether you know that rule or not, they'll ask reversely. How can we declare non-static variable in interfaces? Make it FAQ. How can we declare non-static variables in interfaces? There is no concept of declaring. There is no concept of declaring non-static variables in interfaces. There is no concept of declaring non-static variables in interfaces because the variables are automatically. There is no concept of declaring non-static variables in interfaces because the variables are automatically static variables. Automatically static variables. All of you understood this variable concept in your interfaces? All of you got it? Right. Okay. Now, methods. I'm going with methods. Now, rule 5. Rule 5. Look here. In the rule 5 now, I am taking methods. Already we took methods in classes. The methods which are declared in classes are automatically concrete methods actually. So automatically they are concrete methods. The methods are concrete. So concrete methods means methods declared with method bodies. That's called concrete methods generally. Without method body, you cannot declare methods in classes. So automatically body is expected there. So the methods are concrete methods. And the methods can be two types to you. You know already, static and non-static. Static and non-static. This non-static we call it as instance. So this is the term available for us. You know methods already. Now we are bringing methods into interfaces we are bringing. So we are bringing methods into interfaces. The methods are automatically abstract and non-static. So automatically non-static abstract methods. So automatically they are non-static abstract methods. So they are abstract methods. Moreover, they are non-static. They are non-static. So static not there. Static abstract methods not available. They are automatically non-static abstract methods. Make a statement. Because of this reason, yesterday if you observed somebody 11 a.m., you must observe it because your batch is attending parallelly. Parallelly means for 15 days challenge will be there. If you are really learning here, because some hard work and roughly don't do it. You cannot enjoy and if you want to enjoy the subject, some seriousness must be there. Roughly you attend and you cannot catch it, not possible. If you attend bit seriously from day one also, that only. Roughly if you attend it, one day coming, one day not coming, after 5 days coming, 10 days, grip will not be there generally. But if you observe the 11 AM batch yesterday, if you observed, I opened that connection yesterday, interface. I written some methods there. From that methods, I brought one method as a create statement method. I brought it. I written in your notes with abstract keyword. Whenever abstract keyword is there, indicating the method is abstract method yesterday. Who knows interface there in the 11 AM batch, he will not ask a question. But you people will get a doubt because I am answering to you. Because other batches all completed. Who are attending 11 AM batches, they all completed and came already. Your batch only parallelly running. Your interface running. Their interface you are using already directly. Already yesterday answer came already. Their new keyword not there, but objects came. Today diagram is coming anyway. So their interface is coming to you. Abstract keyword is there. So today the theory is to you. The methods available in the interface are automatically abstract methods. What kind of abstract methods? Means non-static abstract methods. What about static abstract methods? Static abstract methods are not available. So all are non-static abstract methods. Make it. Interface. Sorry, rule 5. The methods which are declared within the interface are automatically non-static abstract methods. Non-static abstract methods. The methods which are declared within the interface are automatically non-static abstract methods. Underline non-static abstract methods. Non-static abstract methods. Underline it. Sir, what about static abstract methods? To be remembered, there is no concept of static abstract methods in interfaces. Make it. Note. N-O-T, note. There is no concept of static abstract methods. There is no concept of static abstract methods in interfaces. There is no concept of static abstract methods in interfaces. Right. Now I am writing one program there. See there. I will take one interface here. I will take one interface here. Interface name, always I take first example as arithmetic. One interface I will take it. Inside this interface, I will take void calculate of int x comma int y. One abstract method I will take it. I will take one abstract method. Just I am highlighting that is non-static. I am highlighting that is non-static. So this is one interface now. Right. I am constructing here. How many of you are attending Advanced Java? I am asking again, don't get bored. Raise your hands. So remaining people also plan it, and because next batch will not come up to 1 month. Batch not there. Up to 1 month batch will not be there. Next batch will not come. Next batch will take almost May. Next coming batch. Almost after 1 month only it will come. Okay. So remaining all options will be there. Every 10 days batches will come. Oracle, HTML will come. Advanced Java will not come. Every 45 days one batch will come. Core Javas will come. Every 1 week one Core Java will come. Every 1 week one Oracle will come. Every 1 week one HTML will come. That Angular, Selenium, Advanced, Springs, every 45 days they'll come. Because we faculties will come there bit late in a cyclic process. Basic courses you can find very easily. Core Java every week will come. Oracle every week will come. HTML every week will come. Angular will not come. Selenium will not come. Advanced Java will not come. Every 45 days in a cyclic process will come. Who are attending full stack batches, adjust the time and attend Seleniums, attend Angulars, attend Advanced Java first. Because in a cyclic process, they will take a time. Understood this point, right? Because already 6 p.m. Venkatesh Manasani started advanced, right? Before that, Natras sir started one advance. Next turn came to me. After my turn, again Natras sir will get a turn. After that, again Manasani will get a turn. After that, I'll get a turn. Understood this point? So, my batch should be released. Means May 10th or May 15th, my batch will be released. 11 AM batch what I started. May 15th, the batch will come out. After that, in a cyclic process, my batch will come. Understood this point? Right. So, 7 AM, immediately the batch may not come. So, somebody asked that question, I understand. Right. After 7 AM, your batch is coming to end anyway. You are nearer. Within 15 days or 20 days, the batch will be ended. Right? So after that 15 days gap will come for you to start Advanced Java. Understood now? So why to 15 days gap means you can adjust 11 AM so that by May 10th Advanced Java will be ended. Core Java will be ended, Advanced Java will be ended, already JavaScript will be ended, Angular will be started, Selenium will be started. So that you will get eligibility for the project. If you have a time by 11 AM, pick it. Because yesterday somebody asked, I'm saying that point to you. Okay, right? Okay. If anybody is waiting for working people are there, sir, I am available by 7. I am available by 6 means again evening 6 o'clock one batch will come Advanced Java. Okay, right? Again 7 one, but all will take 1 month time. So working professionals, they have to wait it. No other choice. Because you cannot spend your time by 9 AM, you cannot spend by time by 11 AM, 2 PM, not possible. That people again 7 will come, but a bit late, you have to wait. Some wait you have to do. Working professionals has to wait for the turn of 7, turn of evening 6, you have to wait it. So remaining people, bit early you close it and enter into the market. That's the plan. Right. Now, first program, I am taking one project, interface application 1 I am taking, click on finish. Always I'll take 2 packages. One is test. One package, M-Access. Under test, I am taking, see there, right click on test here, new. Daily you are creating one class here, no? Down you can see interface. Can you see interface here? Click on that interface. Daily you are creating class, the same way create interface. Click on interface. Interface name you can get. Arithmetic. And finish. This is interface. So I am taking one method here, void calculate of int x comma int y. If I write the body here, error will come. You cannot declare body for here. Abstract methods do not specify a body. Abstract methods do not specify a body. The meaning is we are automatically considering it as an abstract method. Why you are writing the body? That's the question. So I must not write the body. So I must not write the body. This one. Now, this method declared inside the interface, no? It is automatically public. If you don't write public also, it is public only. Just now it given one comment, sir, error to me, no? So the method is automatically abstract. So automatically abstract, automatically public. The methods are automatically public, automatically abstract. If you don't write public keyword also, that is public only. If you don't write abstract keyword also, that is abstract only. That's the point. So this is your interface. Body not there. Now, this method is static method or non-static method? Non-static. Non-static will get the memory within the class or within the object? Within the object. So we have to create object actually. So generally we have to create object. I arithmetic OB is equal to new I arithmetic. I am creating one object. So I am expecting to create one object because the method is a non-static method. Non-static method has to get the memory within the object actually. So I am creating object. Go for M-axis, create one class, demo, interface 1, first program, demo interface 1. This is main class. Import test.star. Import. Now create object for I arithmetic. I arithmetic OB is equal to new I arithmetic. I am creating object. Whenever I create an object for interface, error will come. See there. Error is cannot instantiate the type I arithmetic, means there is no object for interfaces. Remember this point. Interfaces you cannot create object. So directly you cannot create object. For classes only objects will be there. For interfaces object not there. This is error. Compilation error means grammar not available. You cannot create object. So the statement here, rule 5, the methods which are declared within the interface are automatically non-static abstract methods. There is no concept of static abstract methods. Now write rule 6. We cannot instantiate interfaces. The meaning is we cannot create object for interfaces. We cannot instantiate interfaces because the interfaces are abstract components in Java. Underline the term abstract components. we cannot instantiate interfaces because the interfaces are abstract components in Java. Abstract components in Java. Look here, generally abstract meaning is in your graduation study, whenever you started your project in the final year, your HOD will ask you to submit project abstract. Yes or no? The term is available or not available? So submit your project abstract, he says. So you'll prepare that project abstract with 5 or 6 pages or 2 or 3 pages. You'll prepare that abstract and you'll submit to HOD. Then the HOD will ask, what is the meaning of this abstract? Abstract meaning is what I am going to construct. What I am going to construct, that's called abstract. So interface saying that I am an abstract component. I don't have object. What I am going to construct means I am going to give this method to somebody. Somebody will take the method and write the body. Actually. So abstract components means physical existence not available. For them, physical existence not available. Whenever you given the 2 papers to your HOD, the 2 papers he will read it. Means that abstract still implementation not available. So still that project not available means for this abstract physical existence not available. That meaning we call it as abstract components. So interface is a abstract components. Abstract components means physical existence not available. According to object oriented programming, physical existence means memory. Memory means object. Object not available. It's a theory. Make a statement in paragraph. Abstract components means physical existence. Physical existence not available. Abstract components means physical existence not available. Here physical existence means object not available. Sir, if object is not available, then how, sir? What that interface will do? Means the rule is, look here. For you, direct object not available. So this is error. You cannot create object. Error. Then how? Then the rule says that for you, one implementation class will give one class to you. I'll give one class to you. Addition. I'll give one class because class has objects. Yes or no? Already you prepared and came here, right? Class has objects. Class has physical existence in the form of object, right? If you go to an English classroom, they'll say, this is one object. They'll say or not now? Yes or no? This is one object. Chair is one object. Table is one object. They'll say or not now? So they are existed actually. The same way, class object. What is existed means object existed. Example, I am the class. My notebook is object. My notebook is object. How Venkatesh sir teaches means you can look into the notebook. Venkatesh sir content is available in the notebook. Now who is traveling on the road now? My book is traveling on the road. Now one Xerox center person will call one student, give Venkatesh sir notebook, I'll take a Xerox. So he is making a Xerox operation on my object. He cannot call me, Venkatesh sir, come here sir, I'll take a Xerox. No. If you take a Xerox of a class, 0 will come. It is an abstract component. Understood this point now, right? Classes do not have, because I am traveling on the road also nobody knows. Xerox center people also don't know who is Venkatesh sir, but my notebook is available there. If I go in, I will buy my book and come. So big one Venkatesh sir, I'll search it and come. Softly I'm speaking. Of course, they was different. Now, means class do not have any existence here. Only object has existence. Because of this reason, language is not class-oriented language. It is object-oriented language. Yes or no? The language name is object-oriented. So, physical existence has one power. So, who is giving that physical existence means class is giving physical existence. Now, take one class. Now, link this class to this interface. Link this class to one interface. Take one class and link it. Whenever I linked that class to class with extends keyword, I linked. You observed or not now? Here, link with one keyword known as what now? Implements. What is the link name here now? Implements. Now, interface to class, we are using implements keyword. Right? Now that interface is implemented to one class. Now once the class is implemented from interface, one rule is there now. The interface says that take my method. So take my method. So whatever the method is there, take my method. My method not having a body, but you take that method. Now the class says that, okay, I will take your method. Void calculate of int x comma int y, and I will construct the body. I will take the method and construct the body. Now the class which is implemented from interface is known as implemented class. This implemented class will take abstract method signature and construct the body. Now by terminology, this class we are calling it as implemented class. By terminology we are calling it as what now? Implemented class. And that inheritance is single inheritance only. You are linking two components or not now? This also single inheritance only. And arithmetic is the parent. Arithmetic is the parent. Interface is the parent. Class is the child. Still we are under inheritance chapter, don't forget. Because inner class is not entered, no. We are under this also single inheritance process only. So the final rules are like this. Make it. Interface do not have any object. Next to what, sir? Rule 7. These interfaces are implemented to classes through implements keyword. These interfaces are implemented to classes through implements keyword, and the classes are known as implementation classes. Implementation classes. These interfaces are implemented to classes through implements keyword, and the classes are known as implementation classes. Underline the term implements, underline the term implementation classes. Now, there is one rule now. These implementation classes must construct the body for abstract method signatures. They have to construct it. If they don't construct, error will come. So rule 8. Rule 8. These implementation classes must means mandatory, must construct the body for. These implementation classes must construct the body for abstract methods of interfaces. Must construct the body for abstract methods of interfaces. These implementation classes must construct the body for abstract methods of interfaces. Now, based on these 2 points now, let me write one example program. I am drawing one diagram there. This diagram, I will take it into program. This diagram, I will take into program. Here also parent-child relation only. Here parent is interface, child is class. The class by terminology we call it as implementation class because it is taking the method of interface and constructing the body. That's a rule. Okay, right. Now, let me write this program now. Example program. In this example program, I will take iarithmetic.java. This is interface. Addition.java, one implementation. Demo interface 1.java. This is one main class. This is one main class. Right. See there I am writing the program. Anyway, interface is available here. This interface. Go for the class. Addition. Right click on test. New. Class. ADDITION. Addition. I took it. All of you look here. I took one addition class now. Daily return parent class, child class now. Right. Here also addition implements iarithmetic. So whenever I write implements iarithmetic, one error is coming. The error is, see there, the type addition must implement means write the body. Must implement the inherited means taking. Inherited means the inherited abstract method. Inherited means some method is coming from the parent or not now. From that parent one method is coming. The inherited method from the parent, you must implement it. Implement it means write the body. That's a rule. So the type addition must implement the inherited abstract method from arithmetic dot calculate of int comma int. It is giving that method name. So I must take that method. Public void calculate of int x comma int y. Sir, why you are not writing abstract keyword? Why I am not writing abstract keyword means abstract keyword is there means body must not be there. So I skipped that abstract method. Sorry, abstract keyword. Now I am printing now. So system dot out dot print ln some body. I am calculating some sum. Roughly I took x plus y. Now once the implementation completed, now I'll go for main class. Here, import java.util.scanner. I will create one scanner s is equal to new scanner of system.in s.close. Now create object for addition. Now first read x and y. System.out.println. Enter the value of x. Now int x is equal to s dot next int. Enter the value of y here. Here additi addition. Addition AD is equal to new addtion. Addition I am calling AD dot calculate. This is method call. So I created object for whom now? I created object for child class. Yes or no? Inheritance means you have to create object for parent or child. Child. So who is the child here now? Addition is the child. Same inheritance rule only, right? We created. So you run it, the answer will come. 12 and 13, the answer is coming. Anyway, the answer is coming now. Right. Look here. Sir, you are saying that this is parent, this is child. You are saying. Method signatures are same, no? Yes or no, na? Method signatures are same or not? Void, method name, calculate, parameter list 2, type int. Same method signature in parent and child. Overloading or overriding? Method overloading or method overriding? Method overriding. That is overriding only. Sir, how can you say it is a overriding? See that. Here one mark came. Implements test.iarithmetic.calculate. Of course. Implements means we taken and constructed the body. That method is overriding method only. So same method signature is available here. Void, same return type, same method name, same parameter list, same parameter type. So this is overloaded method anyway. Now for this, let me draw one diagram so that you can understand where the interface loads, where the class loads, where the object creates for clarity purpose. Don't forget, this also inheritance chapter only, but we are doing inheritance using interfaces. Understood this point now? Instead of doing class to class now, we are doing interface to class we are doing. Okay, right. Now, execution flow of above program. Execution flow of above program. Class files. Here, arithmetic dot class file, addition dot class file, demo interface 1 dot class file. This is main class. Now they'll confuse one point in the interview to you. If it is a class, dot class is coming. If it is a interface, dot class will come or dot interface will come. Class means dot class is coming. Interface means dot interface will come or dot class will come. Dot class only will come. So generally in the interview they'll confuse you only. Class means dot class coming. So interface means dot interface should come. Yes or no, na they'll ask. Generally, no. The byte code means dot class. Not because of class component. Byte code extension is dot class. It is interface also dot class only. It is not dot interface. It is a dot class. Right. Now loading. So method area where classes and interfaces loaded. Today definition changed. Now heap area where objects are created. Java stack area where methods are executed. Right. Now main class I am not writing now. Main class loaded. The main class will go on to Java stack area. This is main method anyway. Public static void main. We are not drawing the diagram for scanner. Now, value of X and value of Y. X is equal to 12 and Y is equal to 30. Now create object for addition. Addition AD is equal to new addition. Now new means one address created here. Right. Like inheritance chapter only, we want to create object for addition. Addition is a child class. Now, child loaded first, parent loaded first, parent loaded first. So who will be loaded now? Sir, interface will be loaded. Arithmetic interface will be loaded first, having method void calculate of X comma Y. After parent loading has been completed, now child will be loaded. Child is addition. Class will be loaded. Here to here, link is available. So the link is implements link. Implements link. Here we had void calculate of X comma Y. Once the loading has been completed, object creation starts. Once the loading has been completed, object creation starts. While object creation, parent member should come first. Yes or no? Right. So interface abstract method will come first here. Void calculate of int X comma int Y. This abstract method will come first. Body not there. Only that method signature will come first. After that, it will come from the child. Overriding, no. It is overriding. Whenever it is overridden, it is coming with the body. It is coming with the body. Void calculate of int X comma, int y. Override the body. All of you observe that now, right? So abstract method signature came from interface, added the body from your implementation. After this address will be loaded onto AD. Now, remaining, object creation ended, no? Then I will call AD dot calculate of int x, comma, int y. I will call it. So no need to draw, no? Hope you understood, I think. We call this method. This method will come for execution. Void calculate of int x, comma, int y. This method will come for execution. Already the values are loaded. X is passed here. Y is passed here. Now this X is taken here and Y is taken here. So parameter passing anywhere. And remaining already. Will be destroyed. So finally, how the class is loading, the same way interface is loading. Like inheritance process, first interface is coming, then implementation is coming. Here also relation between that class and interface is parent child. All of you understood this? Got it? Right. Look here. Now this is the program. I'll keep here. Continuation. Rule 9. The interface can be declared with any number of abstract methods. No restriction. The interface can be declared with any number of abstract methods. The interface can be declared with any number of abstract methods. Not only single abstract method, it can have any number of abstract methods, no restriction. Rule 10. Suppose interface is having two methods. Example. One interface is there. Interface having two methods. M1 of X, one abstract method. M2 of Y, one abstract method. Both are abstract methods. Both are abstract. Now, I am taking one implementation here. I am taking one implementation class here. I am linking this class to this interface with implements keyword. Observe this, right? Now, once the class is linked to interface now, the rule, it has to take the method. How many methods now? 2 methods. The class has to take all the abstract methods and construct the body. Not only single method, it has to take all methods. So it has to take void m1 of x and write the body, void m2 of y and write the body. So the implementation class must construct body for all abstract methods of interface. That is the rule. Not only single method, must construct body for all abstract method. 20 abstract methods are there, means implementation has to take all the 20 methods and write the body. Make a statement. Rule 10. The implementation class must construct body for all abstract methods. Construct body for all abstract methods of interface. All abstract methods of interface. Look here. So by terminology, we call this method are implemented methods. These methods by terminology, we call it as implemented methods. Implemented methods. Implemented methods means we took the abstract methods from interfaces and constructed the body. We call it as implemented methods. The theory. Class can have implemented methods and non-implemented methods also. Means class can be declared with methods, other than implemented methods. So you can take other than implemented methods also, you can take. Make it. Rule 11. Class implementation class. Implementation class can be declared with methods other than implemented methods. Implementation class can be declared with methods other than implemented methods. The diagram I'll paste here. For demo purpose, I'll paste the diagram. This diagram. Interface holding 2 abstract methods. Implementation class took that abstract methods, return the body. By terminology, the 2 methods we call it as implemented methods. A class can hold the methods other than implemented methods also. That is display. That's the concept. That's the meaning behind this diagram. Right. Here, example program. The same program I'll keep in your book. I'm taking itest.java, iclass.java, demo, interface 2.java. This is one main class I will take. I am taking interface application 2 I am taking. Package test I will take it. Package M access I will take it. Under this test I am taking one interface anyway, that is I test. I will take one class, that is I class. Here I will take one method, public abstract void M1 of int x. So public abstract void M2 of int y. The meaning of that is nothing but you can take any number of abstract methods, no restriction. Now, once the class implements iTest, it has to construct the body for all the abstract methods. That is a rule. Public void M2 int y has to construct it. Now system.out.println, this is the output from M1 of x. Now system.out.println, the value x is equal to plus x. Now system.out.println, this is M2 of y. Now this is system.out.println, the value y is equal to plus y. This is implemented method. Yes or no now? Implemented method meaning is what now? We took from the interface and constructed the body. So this is implemented method. So other than implemented method, I will take one extra method, void das of int z. Just I am educating you. Other than implemented methods, you can take your own methods. That's called non-implemented method. Non-implemented method means this method I not took from the interface. I declared my own method. That's called non-implemented method when compared with the implemented method. Now the system.out.println, the value z is equal to plus z. So this is the method. Same thing I written here. Now create object for child always. So demo interface 2 dot y dot java interface 2 import java dot util import test dot star here. Scanner s is equal to new scanner of system dot in. S dot close. System dot out dot println. Enter the value of x. Int x is equal to s dot. See there, nowhere the parseInt requirement is not coming. Observe. So in the demo practice, it will not come. Specifically, in very less locations, it will come. Right. So create object for implementation. I class OB is equal to new I class. That is implementation object. Implementation object. Always I written notes in Advanced Java also. We use get connection method. I made a statement. I'm repeating. Who are attending Advanced Java? We use get connection method from java.sql.driver manager class to create implementation object of connection interface. I written one statement. You can read that statement very clearly. So here implemented objects will be coming. There, that implementation class you cannot see. That is available inside the method. Not only design part. Right? You can read that notes. Advanced you can understand. ob.m1. Already X is there now. ob.m2. ob.display. So the answer will come anyway. So the meaning of this program is nothing but interface can be declared with any number of abstract methods. The implementation has to take all abstract methods and write the body. Not only that implemented methods, other than implemented methods, you can take your own methods, known as non-implemented method. So that is the information through this program. So there I stops the class by today. Right? Okay. See there, all of you. I constructed this up to here. Interface can hold variable. Interface can hold abstract methods, non-static abstract methods. And interface do not have object. Interface is implemented to one class. That class will construct the body for your abstract method. That's a theory. So where this design is used, tomorrow I'm going to reveal that point. Okay, right. Tomorrow I'll construct the remaining. So tomorrow, first I'll start the class with the next program. Third program I'll start it. Okay, right. So read the notes once and come. Tomorrow I'll start with one program for 10-15 minutes. After that, one assignment. 2 assignments will be given. Because today you are reading the notes, no? Tomorrow you are seeing that notes again in the form of one program. With that program and today's notes, you'll get one idea. I'll give 2 assignments to you tomorrow. After that assignments has been completed, after giving that assignment to you, I'll conclude that interface tomorrow. Interface will be ended. Once interface ended, multiple inheritance models will be started. Because we came here for multiple inheritance only, no? Yes or no now? That models will be introduced to you. After introducing that model, then we touch that abstract class. After abstract class, we go for inner classes. That is the sequence. Correct. Take a break, read the notes and come today. Thank you very much for today.